Look at a map of North America. With its neatly drawn borders, sprawling highway systems, and grid-like cities, the land beneath our feet feels entirely permanent, as if this continent has always been here, exactly as it is today. But the geology contradicts that sense of stability. At the highest peaks of the Rocky Mountains, the exposed limestone is packed with the fossilized remains of ancient marine life. Cross the Atlantic, and the contradictions mount. The rugged stone of the Scottish Highlands is an exact geochemical match to the rock formations thousands of miles away in the American Appalachians. The map we rely on is a temporary illusion, a snapshot of a landmass composed of recycled, shifting parts that have been crashing together and tearing apart for eons. To understand how the ground we stand on was built, we have to wipe the map clean and witness the violent construction of the continent from scratch. 2 billion years ago, there was no North America. The Earth was a volatile landscape dominated by vast primordial oceans. Lurking within those waters was a massive, incredibly old chunk of continental crust known as Laurentia, the primordial bedrock we now call the Canadian Shield. Cooling and compressing over millions of years made this rock incredibly dense. While other early landmasses were ripped apart or melted back into the mantle, Laurentia's rigidity allowed it to hold together. Laurentia became the immovable anchor of the region, the essential foundation upon which the rest of the continent would systematically crash and assemble. The first major addition arrived from the east. Shifting currents of magma dragged the landmasses that would eventually become Africa and Europe on a direct collision course with Laurentia. Hundreds of millions of years ago, these colossal plates slammed into the eastern edge of our primordial seed, fusing to form the supercontinent Pangaea. Immense horizontal pressure forced the Earth's crust to crumple and fold, thrusting thousands of feet into the sky. This created the Appalachian Mountains. Today, they are rounded and weathered, but at the time of the impact, they were jagged peaks that rivaled the height of the modern Himalayas. The entire East Coast remains a massive scar, the permanent result of a singular continental-scale car crash. Eventually, Pangaea fractured. As the Atlantic Ocean opened, North America began a relentless migration westward. During this journey, the leading edge of the continent acted like a giant geological bulldozer, plowing into the heavy rock of the Pacific Ocean floor. It scraped up volcanic islands, small microcontinents, and heavy ocean floor, welding these fragments onto its leading edge through a process called accretion. The friction of this scraping process transferred immense pressure deep into the interior, buckling the crust hundreds of miles inland and forcing the Rocky Mountains into the sky. The vast West Coast is a chaotic, welded-together junkyard of scraped-up oceanic debris. The modern map reveals a patchwork monster of ancient cratons and tectonic scar tissue. These violent construction processes have never stopped. Even now, the landmass is being torn apart. The San Andreas Fault cuts a long, straight scar through the desert, marking an active shear zone where two massive plates are constantly grinding past one another. The Pacific Plate is currently catching and ripping the Baja Peninsula and parts of the coast northward, pulling them away from the mainland. Geology is an ongoing event. The map we memorize today is merely a temporary snapshot in an unfinished, billions of years long story.